What's up guys, it's me Sir Ernest, and today we're going to talk about root finding methods for computational physics and computational mathematics. So for example, let's consider this function. Okay, so our function is a function of x, and that is equal to 2x squared minus 4x minus 3. Now from this equation, we can actually graph this equation. Let's say we set our x-axis from -3 to 3, and then the value of f at every value of x from -3 to 3 can be graphed like this. So you already know that this is a parabolic graph, wherein the lowest point, as we know from analytic geometry, is located at x equal to 1 and f of x equal to -5. Now, what's important for us right now are these 2 points. We call these 2 points wherein these 2 points correspond to the roots of your function. So when we say roots, these are the positions of x, in this case, where your f, or your function, is equal to 0. Okay, so we call this root finding. So sometimes we call the roots to be zeros of your function. Now, typically, if we have a quadratic equation like this, we just use the quadratic equation to compute for the roots. So if we're going to apply the quadratic equation given by x equals -b plus or minus square root of b squared minus 4ac over 2a, where a is 2, b is -4, and c is -3, we end up with these two values. These two values are 2.5811 approximately and -0.5811. So these two values correspond to the values of x where the function is equal to 0. So this is the -0.5811 roots, and this is the 2.5811 roots. Okay, so this is an example of what we call the direct method, or an analytical method of deriving or determining the roots of a function or roots of an equation. There are several other ways to know the root of a function, or at least approximate them. Okay, this is most especially applicable when you have a complicated function. These are the following. So these following methods are called approximate methods because the results that we're going to obtain here are not exact. Unlike when we use the quadratic equation, which is an analytical method. Analytical methods for computations provides us the exact equation. Now, the first one is using graphical method. So when we say graphical method, so this is a we use graphical method to roughly estimate the root of your function. So for example, this function 2x squared minus 4x minus 3, we notice that when we graph this function, we can see that indeed the two roots are located at around -0.5 and positive 2.5. Okay, so those are your estimates, and those are very good estimates when comparing to our actual solutions. If you want to have a more accurate solution or more precise solution, we can also do some trial and error. So if you have a trial and error, so that means you're going to enter many possible values of x, adjust the values of x until such time that when you evaluate this function at those values of x, we choose the value of x where f is closest to 0. Of course, that's a very tedious and very inefficient way to know the roots of a function, especially if you have, for example, if we have a very complicated solution or a complicated function. Now, there are numerical methods that we can employ, okay, to programmatically and in a more efficient way determine the roots of a function. These are the bracketing methods, which includes two major uh, types or ways or subcategories. First category is bisection method, and the second is false position. So generally, this method is called as such because we are assuming we are setting at the start a bracket. So when we say a bracket, uh, by the help of your graphical method, we are going to define a bracket that will include your estimated root. So for example, if we want to know this root, we want to calculate the root here, we can choose this and this as our bracket. So when we say bracket, that is the interval of two values wherein in between them, you expect the root to be located there. Okay? Now the difference between bisection and false position is how the estimate of the root is calculated. So in this, so if we don't know, if we don't want to set the bracketing method, we can also do some open methods. When we say open methods, we use open methods employ even if you don't have two values that bracket. You only need two initial guess to estimate the roots. This includes three kinds of open methods: a fixed point iteration, the Newton-Raphson method, and the secant method. Okay, so for discussion purposes, we're only going to focus ourselves in this here to our with the bisection method. Okay, so the only difference between bisection and false position method is how we estimate the value of your roots. Okay, so in the coming videos, we're going to talk about the bisection method and how bisection method is determined. In case in your MATLAB module, you are also going to look into or study bisection method. So in the following video, I'm going to present to you an alternative way to determine the root of a function using bisection, which is slightly different compared to what was presented in your MATLAB module. Okay, so that's all for now. Thank you for watching, and I'll see you guys in the next video. Bye bye.